Okay. Hey, everybody. This is Sky Nelson, and I'm trying to set up this conversation with Johannan Ratz. We're kind of throwing it together here logistically on Google Hangouts. So let's see if we can get this working here. Pull him in. And I'm hoping you can hear me. It looks like I've got volume there, and it looks like it might be a little loud, actually. So hey, everybody. I'm Sky, and we're going to talk about synchronicity. I'm a physicist, and I do research on the physics of synchronicity and quantum mechanics and foundations of quantum mechanics, cosmology. And Johannan is one of the leaders of the idealist site, studying idealism and philosophy, and website on Facebook. And so I'm looking forward to talking with him. Give us a second. So Johannan is pulling himself into the call here, I think, any minute. What's going on for him? Tissue. There's Johannan.
Hey, Sky, can you hear me?
Yeah. Hey, how's it going?
Excellent. I don't have my webcam, unfortunately, so what's up with the...
All right, I'll be the pretty face.
All right. So we have Sky Nelson here. He is a physicist at the Synchronicity Institute, and he studies string theory at
San Francisco
State University.
Yeah.
And so welcome, Sky.
Master's program. Thank you. It's good to be here.
Excellent. I actually just got done with a master's myself in philosophy. My undergrad was in physics, and then I did philosophy here at Biola. So.
And we haven't met in person yet. Can you tell me how I can address you? Is it Johannan?
Yeah, Johannan Ratz.
Great.
It's Johannan, yep. So yeah, I started out with a physics degree in bachelor's in UW Milwaukee, Wisconsin, and then I got invited out here by J.P. Moreland. He's an apologist and famous philosopher of mind for philosophy. So
yeah, I was looking him up and saw that you had done some physics and engineering. Is that right?
Just physics.
Just physics. Okay.
And then philosophy. I like the interface between the two because there's some of the things they're discovering with emergent space-time, for example, and then there's the tying with consciousness with the observer effect and all that. There seems to be some significant interplay between physics on the one hand and philosophy of mind and metaphysics on the other. And so people like to separate the two, and I know a lot of physicists see the two as anathema, but apparently you're one who doesn't, which I was kind of looking forward to talking to about. So.
Yeah, definitely. And I think maybe I'll just turn off my video so it's not distracting.
All right, that works.
Cool. Yeah, so I'm looking forward to what we get to talk about today. I think there's certainly alignment between some of the dialogue I've seen going on in the Facebook group that I was invited into. And are you a part of that group?
Idealism and science versus atheism, is that it?
Yeah.
Yeah, that was actually technically my group, though a friend actually started it for me sometime back. We were deciding to expand onto Facebook. So.
Yeah, looks really interesting.
Yep. Yeah, so I've seen you had a lecture. It was Alan who introduced me to you, and you have a lecture on deriving relativity and quantum mechanics from consciousness.
Yeah.
You speak a little bit about that?
Yeah. So that lecture a couple of years ago at the Science and Non-Duality Conference in San Jose was a chance for me to explore some ideas that I've been having that are not fully formed yet. We lost you there for a minute.
Oh, you got me now?
Yeah, some noise. So, so I took the chance to explore this notion that there is a mathematical way to represent information space, which is a dual space to physical space-time. We all live in physical space-time. That's what we're used to. That's what special relativity describes. And but there's a lot of intriguing knowledge that we have about the information representation of physical space-time, which the work I'm doing now, I suspect that the Fourier transform, which is a really ubiquitous, important mathematical process that we use in information processing, in audio processing, and things like that. The Fourier transform is somehow really fundamental. In fact, I think it actually describes the information, what we call the dual space, the information space. And so my work in that regard that I'm continuing to do, and the time of that talk was pretty new, but I'm continuing to work on that with the current grant that I have. The idea is to flesh that out mathematically so that we understand that there is a representation in this dual space that corresponds to physical space. And it gives us an overview of why quantum mechanics allows us to have superpositions of possibilities. So essentially there's this possibility space that we can describe just with physics that gives rise to real effects like you and I having a conversation, but it also gives rise to the superposition of those possibilities so that you and I could have a conversation about this, or 10 minutes before the call, something else could have happened and the conversation could have fallen through. And so there's these different branches of real space, of actual things that actually happen. There's different possible branches that we could end up on.
Interesting.
And so I think that's all rooted in this space of possibilities, which I think can be described in terms of information space.
This space of possibilities is essentially the more fundamental realm than space-time and quantum.
That's right. Well, actually, so this is a little complicated, and I'm not totally sure I have it or understand it yet, but there's a dual space, right? There's the space-time, and then there's the information space, and one of them is not more primary than the other. They're dualities of each other.
Okay.
And so the information space is represented by momentum and energy, and we have. So just so you know, we can hear the microphone just changing around a lot there when you do that.
Sorry.
That's good. So energy and momentum are the descriptors, the coordinates for that space, and space and time are the coordinates for the space that we're used to. And so you can start looking at what are the ways in which they relate to each other, because they're intimately related. They're like brother and sister.
Right.
but it leads to this idea that there's that space-time is not the primary thing out of which consciousness emerges. That's certainly not true in this model.
Right. I've seen a lot of people talk about this from a philosophy angle, consciousness being emergent, and then they define differences between like weak and strong emergence. And the problem with consciousness is that when you talk about emergence, you have like say an anthill emerges from sand and ants, but you can always, if you got like a really sophisticated computer, you can compute how all the sand particles go together to create the anthill, right?
Yeah.
But you couldn't really do that with consciousness. You could have a very complex computer computing all the ways that the neurons are interacting, but you never think that would develop consciousness by itself. You could, in theory, predict a P zombie rather than a philosophic zombie, which is I think you might have heard of the term. It's
No.
Oh, it's in philosophy. Chalmers suggested it. It's a zombie or a person.
Oh, zombie.
That,
Yeah.
behaves conscious, and it looks conscious, but it doesn't have anything going on upstairs.
Yeah, we do the zombie blues at the consciousness conference. We sing verses about what it's like to not have any consciousness.
Yeah, so there's no way to actually. So the problem with this is that when they describe this, they're saying that there are these processes that happen, and you could have a zombie coming out of it, but instead of having a zombie, you somehow don't have a zombie. You have consciousness just emerging, but without any explanation from how to get from the substrate of the neurons to the consciousness itself. It's kind of a magical leap. And so
it is a magical leap. I think there are people who've done good work on this, showing that there's something. Well, Chalmers, his idea of qualia and the hard problem is that qualia is a fundamental, irreducible thing that cannot be described in terms of like neural correlates, parts of the brain that are lighting up, and you can't get to qualia from physical space. It's just no. I think I might have been reading something of yours, but I read something recently where any mathematical transformation takes something and transforms it into something in terms of the same thing. So you always get basically the same thing back that you started with.
So, for example, the little live button up in the corner, right? It's yellow. It has yellow color qualia.
Yeah.
But now, if you were to say it's emergent, so the anthill is emergent, you could cut that anthill back up and you could break it all back down to little sand particles. But the problem is, if I zoom in on that yellow sign there, I can cut that in half and I'll still get yellow. I can cut it in half again and still get yellow, and so on and so forth. And you can't say that it reduces. And if it doesn't reduce, you can't really say it's emergent either.
Right.
I mean, they have this notion of kind of magical strong emergence, but if you think about what that actually is, it's a formal non sequitur fallacy. It's a set of premise. He's talking about neurons behaving a certain way, and it proceeds down the line, and all of a sudden you get this completely new conclusion that comes out of nowhere, which is yellow color qualia. Never appeared in the premises, and so it's
right. So how do you get something out as a conclusion out that doesn't appear in the premises?
And the only logical way to make sense of this then is to say that consciousness cannot be emergent, therefore, and must be fundamental, which gives you, if it's a scientific model, has to be in the fundamental realm of physics.
Yeah, and I think that what then comes to my mind is, well, why are people resistant to that? Because it's actually more logical and reasonable to just start with a different premise that consciousness, which we all have and experience, is the thing that's happening, and that space-time and physical objects are a result of that or within that. What's the resistance to that? And I think that the resistance is much more sociological.
Yeah, sociological and psychological.
Yeah.
Because if you essentially see this on two ends. On the one end, you see, the quality of problem is just one issue, right? There's a whole raft of problems in philosophy of mind that don't make any sense on a materialistic or matter first model of consciousness, and yet they have people kind of very stubbornly holding to this. And then the other side, well, there's a sort of assumption that it's going to lead to dualism, which is going to put consciousness outside of science, right? But then there actually is a place in science where the whole reason that it's assumed that consciousness has to be outside science is the subject-object gap, where science deals with the object and consciousness is the subject. But then when we get to the observer effect, we see this nice place in science, the only place in all of science actually where the subject-object divide is crossed, because you have in a quantum measurement, you have something that is part of the objective world. It's an actual thing that happens out there, and yet at the same time, it's something that, obviously conscious observers aren't the only things that can collapse wave functions, but if you were to, terminate a von Neumann chain on your consciousness or my consciousness, it would also be a subjective percept at the same time. So it's simultaneously a subjective percept, and yet it's also an objective thing in physics.
So by von Neumann chain, just to make sure everyone understands what that is, von Neumann was the first one to really look at, well, where does the observer start and the thing they're observing end? Where does the collapse of that possibility happen, the wave function? And he backed up like from, well, does it happen at does the rose become a rose at the edge of the rose, or does it become a perception once the light hits my eye, or does it become a perception once that signals from my eye get to my brain and are perceived in some way? And he was able to show that there's no actual place where you can say that happens. There's this irreducible connection in a way. I mean, this is not the right word, but between ourselves and the rose that we're visualizing or that we're seeing. So, and I can give a little bit of exactly where that math comes from in terms of the observer, what we call the observer effect. So a quantum measurement, a measurement of a system in quantum mechanics involves, we start with, well, the whole problem begins with how we represent objects in quantum mechanics. In regular physics, before the 1900s, we would say, okay, here's a variable m, and this represents the mass of the electron. Or let's use a different one. Let's use x. This represents the position of the electron. And you can actually write, like, if the position is 5 inches from between here and there, you can write x equals 5, and that makes sense. The letter x actually represents the thing itself. It is the thing. You can say they're equal. But in quantum mechanics, the way I interpret it and understand it is that because we're working in this thing called the Hilbert space, everything, the fundamental premise of quantum mechanics is that everything is represented primarily in a Hilbert space, which is it's a vector. So it's a property. Everything is represented by its properties. There is actually no thing other than apart from the properties that it has. And so these properties are represented as vectors in this thing called the Hilbert space. And the vector, we call it a ket. We write down a thing called a ket, and it doesn't actually equal the electron. It represents the electron. So you can't write the ket equals, and then the value, some value. It doesn't actually equal a value. It's an abstract symbol. So what's really crucial about quantum mechanics is it starts from this, the whole mathematical foundation is symbolic. We can write down a ket that represents things in the real world, but it doesn't actually equal them. And so then when we want to find out about the electron, we then have to operate on it. We don't just look at the symbol and know what it is. We have to do something to it.
Right. You got like a momentum operator or position.
Yeah. And those operators are decided on and determined, the form of them is determined by you and I, the observer. So there's no way to get any information out of a ket, out of an electron, without operating on it with something that you and I are going to choose.
Right.
And so right there you have this inseparability between your choice of what kind of operator you're going to measure with and the property that you're deciding to measure. They don't exist separately. There's no way to make any sense of it.
Yep. It's very interesting because you see that and a number of other things in physics that they don't very well fit into a materialistic framework, but they fit into a framework with consciousness being fundamental. Mm-hmm. And on the one side, you see this big mystery in philosophy of mind called the hard problem. Mm-hmm. And it doesn't make any sense in a materialistic framework. On the other side, you have this thing in quantum mechanics where it has this perfect match to concepts related to consciousness. If you just have like traditional objective material objects like in the Newtonian physics, the concepts that you're talking about there, they don't relate to the concepts of consciousness. Neurons shooting, impulses, that could just as well be wires in a computer shooting impulses, right?
Right.
It doesn't make one conscious, and there's nothing that connects it to consciousness. But then with this quantum mechanics, we have this very natural fit of the concepts relate to consciousness in a way that they don't relate to with Newtonian mechanics and science such as chemistry and biology and neurology based on Newtonian mechanics.
Right. Federico Fagin, the inventor of one of the first microchip, or one of the co-inventors at Intel, ultimately went on to do a lot of research on his own on trying to do what you're saying, to get in conscious, or to get intelligence, to get some kind of qualia experience out of a silicon-based device, and ultimately gave up, saying it just you cannot create a living being. And I'm not an expert at how one defines living conscious being, but there are experts. And he said you can't do that. So he switched his efforts to try and understand, flip it over and say consciousness must be primary. And so how do we get physical space out of that?
Yeah, so now two subtopics related to the notion of emergent spacetime, or getting relativity and quantum mechanics out of consciousness, is I noticed that you were deriving spacetime from this phase space, right? And these spaces, the Fourier series.
Mm-hmm. Mm-hmm.
For the wave function. Have you heard of Sean Carroll's work? He has this thing on spacetime emerging from Hilbert space, where he takes the quantum probabilities as more fundamental than space and then derives a spacetime from that.
I'm familiar with Sean Carroll, definitely, but I haven't read that, so I'm going to check that out. It sounds very interesting.
It sounds related to what you're doing.
Yeah.
And you can treat Hilbert space as it's an abstract space that you define wave functions. Actually, it's a little more than that. It's any square integral function with a finite square integral function. It fits into a Hilbert space, and you can treat that as an abstract mathematical space. Yet, when you're talking about in quantum mechanics, there is a sense in which even you can call it maybe a description, right? There is a sense in which you can what it's describing. If those quantum probabilities are not actually in space-time, in reality, there's a sense in which you could say that the Hilbert space is actually describing a real domain of reality beneath space-time. And
well, yeah, I mean, to me, that's a given. I think we're on the same page. So, the way I like to describe quantum mechanics is that in our normal life, we like to think of there's basically things that exist and then things that don't exist. So the earth and the room I'm in and the desk I'm sitting at exists. There's no coffee on my desk, so that doesn't exist. And it's either or, right?
Yeah.
But what the Hilbert space presents is this intermediate space, which is, like the square root of reality. I mean, mathematically, that's essentially what it is. And that this layer of possibilities is a real domain.
Right.
Real, and the way I define real there, because that's a really tricky word. There's so many different meanings to that word and implications. But the way I define real is that it can have that possibility space, that Hilbert space, and the things in it can have measurable impacts on physical space-time that we are in.
Right. Now, connected to that, there is this other thing that it's in a, I shouldn't say totally unrelated field, but it will become very apparent how it's related in just a moment. You may or may not have heard of this before. It's called quantum cognition, and it arose actually from realization that it started out actually by discovering that economic decisions behave according to quantum mathematics. And I thought, well, that's a little weird. And then they kind of realized, well, what is economics happening? People are making choices on what to pick on the stock market, right? What's going on there? Well, it's individual human beings making choices. So if you have, economics behaving like this, then that really means that what it's really saying is the humans behind economics, selling and trading stocks and bonds and so on, are behaving like this. So therefore, human psychology behaves like this. So now, interesting example is, what's your favorite ice cream?
Chocolate chip.
And what is your second favorite ice cream?
Cherry Garcia.
Okay, so you have chocolate chip and Cherry Garcia, and you go to the freezer and you open the door, and they're both in there. But sometimes you're going to pick your second favorite one, right? You're going to pick your favorite. So you're going to sit there, and if you were a regular Bayesian computer, like you've seen, like on the Terminator, he has this, these set of responses, and he immediately computes what's the right response for the situation, right? There's no delay, maybe a split second delay, but it's just like snap his fingers, boom, the outcome happens. If our brains behaved in this sort of linear digital fashion, we would do that. I mean,
Right.
you wouldn't delay in picking which one you pick, right?
Right.
But what happens instead?
You go through a chain of decision,
When you sit there and you waffle for a moment, don't you?
Yeah.
You're neither chocolate chip nor Terry Garcia, but kind of both at the same time, aren't you?
Yeah.
What does that resemble?
Superposition of possibilities.
It's a superposition of possibilities. And that sort of fuzzy logic thinking, that's what they model with quantum cognition. They discovered that this actually, it's not just an analogy. The exact same mathematics that describes quantum superpositions in Hilbert spaces is what describes this sort of fuzzy logic behavior.
Yeah.
And it's very fascinating because they then realize that you can treat these choices as basically being, very complex ones, as simply the kind of quantum computations that would occur in these quantum fields.
So you can maybe apply some of the mathematics onto stock market or onto artificial intelligence decision making or something like that.
Yeah, but not just that, but you'd have to be quantum artificial intelligence, because otherwise you'd have the digital computer doing the stuff. But
the mathematics can be done on a digital computer if it's.
It could be, and you can do that. For example, I saw recently they simulated a 46 qubit quantum computer on a digital computer, right?
Uh-huh.
The problem with that is, though, and you can do that to an extent. The problem with that is, though, is that when you have, a qubit, you have a 1 and a 0 in the same state, right?
Yeah.
The same bit has two states at once. But now the classical analog only has one state, right?
Right.
So for every qubit, you have to have twice as much hard drive space in a classical computer.
Right.
Every superposition. So then
you to the 48th.
Exactly, and so they had a very large classical supercomputer that was able to store all the space for that 2 to the 46 power stuff, right? But the problem is that obviously with quantum computation, it goes way past that.
Right. Yeah.
And our brains aren't supercomputers by any stretch, and so the thing is you could in theory do that to an extent, but the problem is that very quickly the hard drive space would expand way out of control, and at the same time the processing power would double.
Well, so here's an area of interest of mine that I think is important here. And I am a physicist. I'm not a neuroscientist or biologist. I'm not good at biology. But my understanding, just from the data I've read and the things I do understand, is that the eye and the ear, probably all the senses, perform a Fourier transform on the incoming sensory data in order to store it in the brain, in order for it to go into the brain.
Right.
So, and I suspect, and maybe this has already been figured out, I just don't know, if you have, say, what is it, like 1 trillion different cells inputting data in your eye, let's say in your cornea or whatever it is, and then those nerves all come together as the way we know nerves do, right? They're a network, so they're like a branching tree, but in reverse. And so from those trillion bits, you come down to like 1 million bits, which is an order of magnitude of 1 billion decrease. Right. So now you've got this incredible mixing of the data. And a Fourier transform is a similar process where you're essentially taking all the data you have, like let's say it's a sound wave from an MP3, from a wave file from your music, your favorite music, and you mix that thoroughly intermixed, kind of like you're mixing all the ingredients for cookies. You mix it so every part of every ingredient is mixed with every part of every other ingredient. And that's what you do with the sound file in order to get the frequencies out. And that's what you do in this example of the nerves coming together and basically sharing all the data that each one has with everybody else together. And so then you get a trunk of that tree coming into your brain, which is a thoroughly mixed signal. And I suspect that that's a Fourier transform of the original data. And so the data going into your brain is Fourier transformed. And interestingly, in parallel, the work that I'm trying to do is showing that the Fourier transform is the space in which quantum mechanics is happening. So I don't have a connection there to make explicitly, but I think that when we think about computing quantum computers with single bits and how to build them up from single bits, we might be missing the boat. I mean, the the Fourier transform is a very, very powerful and can be done nearly instantaneously with the right architecture, like the brain or like the nerves
Right.
in the eye. That doesn't require a supercomputer or all these bits. It requires a certain architecture.
So you can reduce any structure into a simpler structure with Fourier transforming is simply the simple example would be like the square wave, where you have a whole bunch of waves that are generating this square pattern. And you can, but the interesting thing about this is way back I learned this in college math. It was Dirichlet's conditions, and basically what it pointed out was that you could take any complex structure and reduce it down into these sine waves.
Right, and you're not necessarily you're not necessarily losing anything.
Yeah,
you're not actually making it simpler, but you're putting it in a form that is simpler.
Exactly.
To understand.
It's more compact, basically.
Yeah. And to get back to the beginning of the conversation, it's I believe a parallel or dual space that's equally, in every way, equally valuable and useful and descriptive as our physical space-time.
Yeah. Now, what I want to point out also, because obviously quantum mechanics is done in the language of Fourier series, right? The tie-in with quantum cognition and the whole issue of there's still a lot of qubits that would be unpacked, and it raises given that we already strongly suspect that consciousness has to be quantum mechanical because it naturally fits conceptually, whereas the material model does not.
Right.
It raises the question as to whether this is not actually more than an approximation and is actually literal quantum biology in the brain that's causing this literal quantum entanglement.
Yeah, I've heard that.
Wave functions.
Yeah.
And it makes sense. And the interesting thing about this is if that's the case, the consciousness would be in the wave function beneath the space-time. Now, here's the thing.
Tricky.
Here's the interesting thing about that. Okay, this is where it ties in very nicely with the philosophy. Okay, if I were to open your brain up, do brain surgery, and you open you up, and you were to be thinking of chocolate chip and was it cherry? Was another?
Oh, Cherry Garcia.
Cherry Garcia. Okay.
Yeah.
You were to think of those things, or you think of the number 2, or the color yellow up in the live button, or what have you. I would open your brain up. I wouldn't find those things anywhere, would they?
No.
I just find a bunch of gray matter shooting, electrical impulses off.
Right.
And if I were to ask where in space I could find those, or in time, outside the actual real things of them out there, but I'm talking about the concepts of them. Or to ask, where could I find those in space or time? It wouldn't make any sense as a question, would it?
Right.
Those things are not in space-time, are they?
Right.
Well, quantum superpositions are not in space-time either, are they?
Right.
And if quantum cognition is right, those thoughts and ideas that we're having are in quantum superposition.
Right.
Not in space-time. And what's funny is then you see this parallel because you have on the one side this sort of Platonic ontology where these ideas are not in space-time, and you go over to the physics and you find out that if you model them with this quantum cognition, literal quantum cognition, with this notion of this Hilbert space being more fundamental than space-time, they're also not in space-time. It's the same, not in space-time.
Yeah. And I think that there's a tendency to jump. I think this is a good foundation, and there's a tendency to jump quickly, but it's a good enough foundation that I think one should proceed pretty slowly to really figure out that relationship. Because I don't think we're saying that thoughts are like equivalent to quantum superpositions of an electron, or that I feel that we're certainly not saying that the wave function is conscious or that consciousness resides in the wave function. I think we can be a little more specific and say, well, for one thing, the wave function arises out of consciousness, or consciousness is the background, the Hilbert space, out of in which the wave function exists, and that they're equivalent.
But they're equivalent, but there's a little bit of the wave function is a description, of course, and in reality it's the quantum probability wave, and there's the
Yeah, and I think people get a little turned off when they hear consciousness is inside of something, because then we get into pantheism and like, well, is an electron conscious? And those are like, I think they're not helpful questions.
Yeah, that's probably right, because it's not like an electron. It's well.
The question is, the electron arises out of consciousness.
Yeah, there is a guy, Donald Hoffman. You might have heard of him.
Yeah, I've done some work with him. Or,
He had derived the wave function from conscious agents.
Yeah,
it's this really cool derivation, and so it's not, the electron wouldn't be conscious; it would arise from consciousness, though.
Yeah.
So the wave function, it was kind of an interesting idea, because the consciousness is more fundamental than the wave function. But so
I think that's really important. We can say just what he said, that the electron is not conscious. That's a meaningless statement. We're saying the electron arises in consciousness, because all physical objects are symbols representing a physically interactive reality, but the symbols are not the thing itself, which is like what we were saying.
So if I have a dream and I see a tree in the dream, the tree is not conscious, but it's in consciousness. It's in my consciousness.
Right. It's a good analogy.
Yeah.
And Donald Hoffman uses the example of, for instance, on my broadcast screen for the Google Hangouts, there's a stop broadcast button. At the bottom, it's red. It says stop broadcast. So that button, if you just take a screenshot of that button, let's say you put the screenshot on you took a snippet of that and put it on the side, and you tried to click that, nothing would happen. It's equivalent in all ways except for its symbolic representation. Because what it can do if I actually touch the right button is it can turn off the broadcast and change physical spacetime. But there's no switch. He talks about how that is representing an action, but it is not the action itself. And the concept of turning off the broadcast resides in the button that's actually there. Whereas if I just took a picture of it, that's not there.
Yeah, it's not exactly.
So I think
I've heard him in a talk use the notion of desktop icons.
Yeah. Right.
Desktop icon is not the actual program itself; it's representation.
Right, a useful representation.
Yep.
And I don't know that I'm doing it justice, but that sort of came to mind.
Yeah. Yeah. So it's really kind of interesting to think of, our immediate introspection as actually belonging in the realm of that. Because when people talk, I've seen people in quantum gravity talk about stuff beneath space-time, and they talk about it like, even you might have heard of Fotini Markopoulou, a loop quantum gravity theorist, right?
I haven't.
And she's a famous loop quantum gravity theorist, and she was closer to the truth. And they were talking about this, and she's saying, we discovered that it seems that space-time is not actually fundamental. And then Lawrence Kuhn was like, it's like not fundamental. Like everything we think of is happening in space-time. It's just like, he thought this was quite extraordinary, and she was like, yeah, she was like excited about this, and like, this is remarkable, and she has no idea what this was, and she knew it was there, but it was like mysterious, right? Mm-hmm. And it seems mysterious on the face of it. It sounds mysterious, but then you switch this into this consciousness framework, and it's very fascinating then, because it doesn't seem, once you realize what it is, it's not mysterious anymore, but it's also at the same time equally astonishing, because there's this notion that those thoughts that you're having, that you actually have direct access to the beneath space-time realm in a very immediate and intuitive way.
Right.
It's all the thoughts. You're actually interacting with the mysterious beneath space-time stuff of quantum gravity.
Yeah, and I take that in another direction as well, which is that we are absolutely interacting with that realm all the time. It's right here. We are immersed within it like an ocean. Yeah. And that's where I think synchronicity comes from. That space and time are a single branch of this branching tree, or it could be described as a branching tree in that Hilbert space. And we're just one of those branches at a time, at a given time. And as we move along those branches outward on the tree, we have, we can describe the evolution of our lives from that, from the tree, on that tree. And the way I see it in my everyday experience is looking and noticing how coincidences show up, and how a moment before a coincidence happens, it was undetermined whether that coincidence would show up. I mean, I certainly didn't know.
And
But into my frame of consciousness comes this experience that's sudden and unexpected, and evolved out of that superposition of possibilities.
Right. And that actually is interesting because it ties into something else you talked about in one of your talks is MQS states, or macroscopic quantum states.
Yeah.
And of course, they talk about decoherence. People have this notion of decoherence where they try and say the conscious observer isn't collapsing it, the environment's doing the collapsing. Well, if you take the and MQS is it derives from solid physics. They had a test in 2011 on the Leggett-Garg inequality where they falsified macrorealism, or the notion that you can just sort of like keep quantum mechanics to the tiny scale and not have it scale up, right?
Mm-hmm. Right.
So that's been falsified. That doesn't exist. Doesn't work like that way. And if that's true, that means that the environment is necessarily that itself. The problem with the environment collapsing the wave function is that the environment itself is in the wave function.
Right.
The environment is something that you can collapse as well.
Right. Yeah.
And so, well, who collapses the environment's wave function? And so that kind of shoots on the entire decoherence argument, because it just shows that it's necessarily false with the given physics we have.
Well, I'm glad you brought this up. This is actually a focus of my research, because ultimately the model that I have to rely on in order to have synchronicity happen, which we haven't talked about, but is the model of relationality, that everything that occurs, every measurable thing that occurs, is happening in relation to the measuring apparatus.
Right.
And essentially that there is no objective, definite space out there against which we're measuring. And this is it's a fundamental choice you have to make, because from that fundamental choice, everything looks different. And I completely agree with you. And I'm actually looking for the paper that I had out here that has a quote. It's by Zurich, who wrote the original papers on decoherence. And there's a line. It's really just like one line in the first couple pages where he says,
"You showed that to me the other day, actually."
Yeah, I mean, it's
the assumption that the environment there's an actual objective environment out there doing collapsing, like.
And it's such an assumption that he basically states it and said it seems reasonable that we can always assume that there is an environment for every system we choose. But what he's really saying, the assumption that I think is hidden in there, and I have deep respect for his work. I mean, he's done those papers he's written are incredible, and they're correct, except that there's an assumption that they're correct only under that assumption, which is that there is a definite objective environment for every system you could choose.
Yeah,
he writes out of hand that there is no possibility of superpositions of those environments. And so within the context of what he's saying, yes, all that decoherence is correct. But within the larger context of relationality, decoherence is only true between systems relative to each other.
Yeah. According to Wigner's friend and the cat are both in superposition together,
Yeah. Yeah. And so what's interesting to me about macroscopic quantum superposition and the argument around it over the years is that, I mean, the whole motivation for people like Zurich to do that kind of work is they start with the assumption that the everyday world is not quantum mechanical. That's the assumption that most physicists have started with in the last 100 years. And then they go about trying to explain why that is, and they come up with this theory of decoherence, and mathematically it does show that decoherence occurs between one system and another. Especially if one system is really, really big, like the quote-unquote environment, then decoherence is going to happen quickly and irreversibly. But that's all based on, here's what I know is true, and here's how I'm going to try and show that to be the case.
Right.
And I take issue with what they know is true.
Yep. Because there's no, actually, we don't just, they don't just know it's true, we know it's false now because of the Leggett-Garg inequality test.
Mm-hmm.
They've actually falsified that.
I'm not familiar with that. I'm going to look that up.
Yeah, it's inequality that would be true if the environment is objectively real, and it gets violated.
Oh, okay. Well, yeah. I mean, and there's some great papers by Merman a physicist that showed that, exactly how the Bell inequalities and the experiments that have been done show that properties do not exist independently of
Right.
measured. So that's really well established.
Yep. So it's really interesting then, because if you have whole states in superposition together, right?
Mm-hmm.
There is this curious situation with excuse me, my throat's got a little bit of acid in it right now. I'm sure you've heard of the quantum erasers, where the past is not defined before you measure the present.
Mm-hmm.
Well, that can apply to an entire room, or an entire, you could have, say you have a synchronicity related to books or something, right?
Right.
Or people or whatever, right?
Right.
And before you open that, there's actually no one really there,
Right.
Unless you have some prior knowledge of someone going there. From your perspective, all kinds of people could be in there, and it could just align that way.
Yeah. Right. So if I go to my book and I'm looking for information on, what was it last night? I was looking for information on Noether's theorem, which is a thing in physics around symmetries and conserved things like conservation of energy. And if I was to look like a computer does, I would go book by book, word by word, and look for that stuff, right?
Mm-hmm.
But instead, what I believe can occur is, or I suspect, I hate using that word believe because it's not about belief.
Yeah.
It's about what's true and what's not
right.
true. So I suspect that the bookshelves and how they're arranged right now is not defined until I look at it, because there's a lot of things that could have happened over the past 2 days or 2 months about where books got put and how they got moved around by whom.
Right.
And what's there is not predetermined. There's a lot of histories for each of those books that have led them to be in a superposition of places right now, and one of those places could be the bookshelf. And so when I go to the bookshelf, with an open mind, I look for the title that catches my eye, or something that I didn't know I had, or something I was looking for. And pretty consistently, I would say inevitably, I do find what I'm looking for. And that's why I talk so much about why flow is important, because getting into a state of flow where we align with the circumstances allows us to find the information we need much more effectively than trying to control it.
Yeah, it was interesting because I want to talk about the details that are a little bit personal, so I want to talk about it on the air. But I had a flow just of what you speak happening for the course of almost an entire year.
Mm-hmm.
It was all related to a certain thing, and it was very powerful synchronicities almost every month.
Mm-hmm.
And it was so powerful. I've heard that the outer bound of requirement for proof in science is something like 1 in 10 to the 50th.
Mm-hmm.
Right? This surpassed that. When I put the numbers on these synchronicities, it surpassed that.
Oh, I've done some work trying to calculate synchronicities probabilities in my life, so I'd be interested in.
I mean, it was kind of a rough thing. It wasn't like a very rigorous thing, but
it has to be. It has to be. Yeah.
It was enough though that it at least beat the odds of winning the lottery 6 times in a row.
Well, so here's the other way to do the calculation: is if you have a lot of little synchronicities, you have every day you have a couple of coincidences that seem unusual. Sure, each one of them can be explained away, but if that's what's happening many times a day, that's a different set.
You build them up, and these were very powerful ones. So it was like, in one case, it was a person at a university had picked up one of my one of my videos, and he was using it in his lectures.
Mm-hmm.
And it was the first person in the entire United States to do this, right?
Mm-hmm.
And it was interesting because the university that he was speaking at was relevant to my synchronicity chain.
Mm-hmm. Mm-hmm.
It was, the odds of that were just astronomical. Right. It was like, this is incredible.
That's cool. Yeah.
Out of all the universities in the entire United States, he happens to be at the one that was synchronistically relevant.
And so I'm passionate about making this the norm. Like, this is not something we should look at and go, oh my God, how did that happen? We need to look at it and say, well, there's a reason. There's a method that's happening. There's the physics behind it. And the physics is that you start with a relational world in which the things you measure are relative to you. And you have to do a lot of work to show that that's not a solipsistic point of view. And I've done a lot of that work. I've tried to, at least.
Yeah.
But barring that for now, the observed world you're observing right now is all that is actually in definite form from your perspective. And your perspective, as we know from the experiments we were just talking about, properties don't exist without a measurement.
Mm-hmm.
They don't exist in definite form, I should say, without a measurement.
Yeah.
So the books on my shelf don't exist. The properties of them don't exist in definite form without a measurement of some kind. And whether that's a conscious person like me or just, rain dripping off the ceiling, or, from the ceiling and wetting them. I mean, we can talk about what constitutes measurement and how interactions happen. But the point being that those realities are not formed until an interaction occurs, like between me and the books. And at that point, one particular chain of histories, of events, falls into place to bring that book to that point on the shelf at that moment.
That particular chain of histories is interesting because it exactly parallels the whole quantum eraser chain of history of the electron going to either as a particle or a wave. And so now here's the thing: is in the quantum eraser, you can choose which way it goes through by the choice of measurement, but you're not always doing that when you go search for a book in a room, for example, right? The reason I'm bringing up the books is because it turned out that the first synchronicity that started out that whole flow of synchronicities that year it related to a synchronicity with a book, but it's a whole other thing. But the thing about this is usually when synchronicities happen, they don't. And I might mention that one synchronicity that happened when I was, 21, way back, right? You're usually not, you're not controlling. Some of them just happen. They're not like you're not making a choice in like the quantum eraser experiment when you're saying, "Am I going to measure this as a particle or a wave?" Right?
Right.
They just happen. So the question is how do the ones that just happen, so to speak, how does that occur?
All right. Well, there's one thing I'd like to say, that we don't actually choose to measure things as particles or waves. I don't think, although I might be misspeaking. Every time we measure something, it becomes a particular form.
Right.
There's a definite outcome.
Actually, you're not. You'd be either measuring as a particle or letting it go through as a wave without measuring, essentially.
Right. So the wave is unmeasured, though it's a probability wave.
Yeah.
And this comes back to the MQS states, where one of the things that I find so frustrating about the way that physicists have over time started with the premise that quantum states don't exist in the regular world, and so then how are we going to explain that, even though the math doesn't show that? The problem with that premise is that we don't actually ever see quantum states anywhere in the microscopic world or the macroscopic world. And so to look for quantum mechanics in the everyday world, to look for a superposition of my chair, doesn't make any sense.
Because the very notion of looking for a superposition means that when you see it, it won't be a superposition.
Exactly. You don't ever look for the superposition of an electron. What you calculate is the probability that it will be in one place versus another because of the interference of the double slit. So you never see a superposition. And so you would never expect to see that for a chair or for an electron.
Yeah, so now the quantum probability space actually would be what determines these synchronicities, essentially.
Yeah.
Now, what's interesting about that is when you transfer in the quantum cognition concept, right, you have this notion of, that quantum probability space is inner space, essentially. Now, of course, a lot of it will be unconscious to you. I mean, the quantum probability space behind my computer, for example, or behind, my bed or your chalkboard, your blackboard or whatever on the, inkboard, rather, I think it was. We don't have introspective access to any of that, But nevertheless, I suspect that there are, if conscious realism is true, there's consciousness behind that. Not that it is conscious itself, but it's being generated from that, right?
Right.
That would be unconscious with respect to us, right? And
why do you say that?
Well, because we can see the board, but we can't see the consciousness behind it.
Oh, okay.
We can see the consciousness in our own individual mind. So, with respect to us, it would be unconscious to both of us, right?
But let's stop there for just a minute. Let me ask you a question. Can I see the consciousness in you?
No, that would be unconscious to you. Not
so we don't see consciousness anywhere. We just experience.
But not see. I shouldn't say see. I should say experience.
Okay, so we experience one consciousness all the time, and that's our right.
Exactly. What I'm saying is we don't have introspective. instead of saying the word see, I should say we don't have introspective access to the consciousness behind
to anything other than ourselves.
Exactly. The rest of it is unconscious with respect to us, right?
Right.
So now, what's really fascinating about this is that it's actually unconscious to a lot of people, and you usually just think of it as if you're kind of a naive materialist, it's just a naively materialistic item there.
Mm-hmm.
There's nothing special about that. But then you bring into this whole framework with the quantum probability space and having a cognitive aspect. It's collectively unconscious, which, as you know, that's a term not from physics, but from Jungian depth psychology, right?
Yes.
And what's fascinating is, there are these patterns in there that will determine synchronicity, right?
Mm-hmm.
But these same patterns, if the quantum probability space is cognitive, would have imprints into our consciousness, right? It could actually have a joint imprint into both of our consciousness, in theory.
Mm-hmm.
And Jung would refer to this as archetypes, right?
Right.
And what's fascinating is he also described synchronicity in terms of archetypes. He mentioned there's one example of someone was dying, right? And at that very moment, there were a big flock of ravens appeared, right?
Mm-hmm.
Well, raven, you've heard of
mm-hmm.
Edgar Allan
Symbolism.
Poe's sort of gothic symbolism of the raven having this sort of like ominous, quality related to death.
Yeah.
The Morrigan in Celtic mythology has the raven, and she's like this banshee goddess, right?
Mm-hmm.
And she's related to death and all that. And so this archetypal symbolism is there, right?
Mm-hmm.
That ties the raven to death, right?
Mm-hmm.
And so what's fascinating is then you see this actually take place in the world. Is right when this guy dies, there's this big flock of ravens fly over, right?
Mm-hmm.
And so you see that, and he's pointing out that these synchronicities are archetypally connected.
Right.
And another example he gave was this patient was talking about a dream she had with scarab beetles, right?
Mm-hmm. Right.
Right at that exact moment, a golden scarabæid beetle flew. He had an open window, right? And it was usually things are out in the sun, and it's kind of a rare beetle anyway. But this was the window was in the shade at the time, and anyway, despite that, this golden scarabæid beetle flew right into the room right as she was describing the dream, and looking at this they're both looking at this in shock and like, oh wow, look at that.
Right, and he was particularly moved by it because that connection broke her open.
Yep.
So, in her own process of trying to do psychotherapy.
Oh yeah, you remember that. That's
right. Yeah, it was the necessary catalyst for her. So there's some meaning and purpose to that.
Exactly, and it's not disconnected in any sense because her inner cognitive state is directly connected to the not that she's introspectively aware of it, but at an unconscious level, there's a deeper level of entanglement beneath that, shall we say, not at her level, not at her frame, but at the frame just below her, would be correlating her cognitive processes with the scarabæid beetle with the dream.
Yeah.
And
that's something that I think about a lot. I'm writing a book right now that talks about symbolism, but it's not from an abstract point of view, from saying that, look, Kets and Bras and operators in quantum mechanics are symbols in Hilbert space. And there's this whole realm of human experience. In fact, the fundamental realm of human experience, I think, is symbolic.
Mm-hmm.
That
I would agree, yeah.
Things represent other things. Thoughts represent experiences. But it's and qualia, and this is really the beginnings of the exploration for me. Qualia are the fundamental units of experience, and they represent essentially the fundamental units of feeling or emotion, or feeling grows out of qualia ultimately. Qualia is the little seeds that give rise to what I call symbolic felt experience. And it's a symbolic felt experience that determines, and I'll just give you a little bit of the math of that I've been working on for this paper, that if you take this branching tree of possibilities, which represents a bunch of parallel quantum histories of how things could go, how they can evolve over time, and you essentially cap them at the bottom where you are, and at the top of the leaves, or where all the leaves are, you cap them with your symbolic felt experience, you can do a calculation which it's like a sandwich, right? The bread on top and bottom determines the symbolic felt experience that you are having, which you're also projecting out into the future where those leaves are, and saying which of these branches lines up with what I'm feeling right now. And you have to really, don't get caught up in the word feeling. It's not just I feel sad, so I'm going to bring about sad things. It's much more subtle around qualia. It's like I am feeling this like I'm an infant and I have an urge for coffee. Like it's just a symbolic felt experience of what that's like to have coffee. And there's a part of me that's wanting that I will cap the tree branches in such a way that makes the branches in which I find coffee a little bit more likely. And you can do that calculation and show that those branches become more likely. And that leads to something like my wife accidentally left a cup of coffee sitting on the counter that I can have, which wasn't there, half an hour ago. That's synchronicity.
It's funny. So these, you could actually, in theory, kind of guide these, I'm guessing, it seems. Not guide them, but, direct them somehow.
Well, we're always directing them. We're always influencing them because our chosen symbolic felt experience, the way that we feel about the things we're doing in our lives and the way we choose to act, ultimately it comes down to what we do to act. That is constantly building momentum towards those branches which align with what we're doing.
Right.
And so one of the problems we have is we're always shifting direction. Like we don't believe in ourselves enough to keep working on something until it manifests itself.
Speaking of that, you want to hear something funny?
Yeah.
I was in Las Vegas visiting my brother at the time that you contacted me when we first met. But right before that, before I left on my trip, a friend of mine felt that I was going to told me that she felt that I was going to have meet a contact when I was in Las Vegas. Not in Las Vegas, but while I was there, I was going to meet a contact.
Yeah.
It was important to that you show up.
Oh, and that was me.
Yeah, you were the synchronicity.
Wow, that's cool. Yeah, and I'm very fascinated by how, the relational model is that everything is relative to our experience of it. And yet we are intermixing with each other. And this is why it's not solipsistic. You have to get into it.
Yeah. Well, and the other thing about that is, that notion that, she felt that this was going to happen, that would seem spooky, right?
Mm-hmm. Well, not to me, but sure.
It's not. If it's, on face value, you might seem that way. But if you're thinking about it from the fact that there's this quantum probability space that is connecting that, right? Just like the scarabæid beetle was connected to Jung's patient, right?
Right.
That's not mysterious at all. It's just it's because that link is already, the structure is already there in the Hilbert space.
Yeah, right. I mean, if you think of, it's like network theory in some sense, although I have no idea what that is. There's this big network of all of us interacting, and the question in my mind becomes, how do we start to rely on that network to bring us what we need in order to start solving problems?
Yeah, it's very fascinating because this notion of, synchronicity is a thing that I was always wondering how it made sense. I knew it had to relate to quantum mechanics, and I had these issues of just, I experienced a lot of them through my life, right? And it was very obvious, and I know a lot of people have as well. I've seen some that are very powerful to the point of you can't explain this in another way. And the thing about this is when it makes sense now. The whole framework makes sense, and it ties this non-materialistic physics in a way that is very practical, and it's not mysterious at all.
Right.
This is what you're describing with synchronicity, how I tied it with the collective unconscious notion. Both of these concepts, they fit very directly in with the physics.
Right.
In fact, I didn't talk about synchronicity in this one, but it was for the kind of collective unconscious concept. I have a video on, they call it Through a Mirror Darkly. It has a purple matrix code on it. It's on my channel. You probably see it when you're on the front page. And it was talking about basically emergent spacetime from Hilbert space, and then connecting that to the quantum cognition concept. So you have spacetime emerges from a giant shared inner space.
I think that my guess is that 50 or 100 years from now, this understanding of how coincidences happen and they actually are related to consciousness and the experience we individually have is going to be understood in the same way that the the waves being given off by your cell phone are understood. Like you hold a cell
Yeah.
phone and you make calls, and you may not understand how those radio waves are interacting with the cell phone tower, but you're surrounded by those waves all the time, and it's not
These are
mysterious
just
because
Hilbert space waves instead.
yeah, and they're different. I mean, I'm not suggesting that it's the
It's
same.
the same, but it's the same. It'll be known in the same way.
It'll be known in the same way. Yeah.
Now, what's fascinating about this is the whole notion of the quantum non-realism, and if you see the way that the physicists are describing emergent spacetime right now, and to the average person, this sounds insane, right? But then you point out the actual quantum gravity research, and you're like, oh my goodness! And it's not just a couple of them; this is uniform across the board, right? String theory is saying this. Loop quantum gravity is saying this. Causal dynamical triangulations is saying this, and there's a twistor theory, I think, all down the line, which these combined comprise about 99% of the field, right?
Right.
They all disagree in some details of their respective physics, but one thing they're all agreeing is that spacetime emerges from information.
Right.
And it's not fundamental. And they're saying, like, Fotini Markopoulou, as well as Lee Solomon, would say that, like, space is just outright an illusion, right? And when you think about that, it's a very, very strongly immaterialist kind of view. It's like a matrix simulation in a sense,
Right.
And it's a matrix simulation being run from the collective subconscious.
Right.
And this is all very solid physics. And what's spooky about this is, not spooky, but interesting about this is about as immaterialist as you can get, and yet it's all very solid, matter-of-fact science.
Yeah. Yeah, I agree.
And people aren't realizing, and from a sociological perspective, people are not realizing this yet.
Right.
When they realize this in mass, it's almost going to be like, it's going to feel like I shouldn't say catastrophe, right? Because I mean, it could be a positive thing as well, but in terms of like the shock value, it's going to cause a lot of, shall we say, psychological and social disruption when this is realized.
Yeah, we'll see. So I suggest we follow this up again and do a follow-up video and get people involved. And I think we have a lot more to say. Why don't we take this up again in the next time?
Let's do that.
That'd be great.
It was good having you, Skype.
What's that? Yeah, thanks for having me and great questions.
Yeah, when you're off air, I'd like to catch up on a few things also. So
that sounds great, and we'll prepare next time maybe to talk about emergent space-time from information.
Yeah, sounds good.
All right, talk to you soon.
See ya.